On a snowy day at -6 degrees Celsius, work begins to start a John Deere Model R tractor. While the main diesel engine is in good shape, the small two-cylinder gasoline starting engine refuses to run. The carburetor is clean, but repeated use of the choke floods the engine. The spark plugs are removed and left out for 2 weeks to let the fuel evaporate and dry the cylinders. After reassembly, the battery connections and ignition switch are checked. In the cold, the engine resists starting, but repeated hand cranking circulates fuel and encourages ignition. Gradually, the engine shows signs of life. With patience, the starting engine finally fires up, running steadily. Once running, the decompression lever is used to spin the diesel engine. Fuel is introduced, and the main engine starts, overcoming the cold with a deep roar. This successful start highlights the importance of drying flooded engines, maintaining strong electrical connections, and the persistence needed to operate vintage machinery in winter. It's a testament to the resilience and mechanical simplicity of the Model R. The 4-cylinder Gegen-Coulter motor M422 is a 4-cylinder opposed piston engine, known for its compact design and efficient power output. Featuring 2 pistons per cylinder moving in opposite directions, it eliminates the need for cylinder heads, reducing weight and improving thermal efficiency. Originally developed for specialized applications, the M422 delivers reliable performance, smooth operation, and durability in demanding environments. The Farmall Super BMD, built in Doncaster, England from 1953 to 1959, is the British diesel version of the Farmall M. Powered by a 4.3-liter engine producing around 50 horsepower, it features a 5-speed gearbox and optional hydraulic lift. Variants included wide track, single-wheel, and dual-wheel setups, offering versatility in the field. Starting a BMD involves checking oil, coolant, and fuel levels, then priming the fuel system, especially after long idle periods, by bleeding air. Switch on the ignition and engage the starter. If it fails to start, check the battery and connections. Once running, watch for leaks, odd noises, or other issues. The BMD remains a celebrated piece of British agricultural history. The Deutz BF6L913 is a robust 6-cylinder, air-cooled diesel engine widely used in construction machinery, generators, and pumps. Renowned for its durability and reliability, it operates efficiently in harsh environments where liquid cooling would be unsuitable. Powered by diesel fuel, it delivers high power output relative to its size and weight, making it ideal for demanding applications. Available in various agricultural and industrial configurations, including the BF6L913C, this engine is celebrated for its longevity, often exceeding 20,000 operating hours with proper maintenance. The second engine of the turbocharged is a powerful MTU V10 diesel with a displacement of 37.4 liters and a 40-valve configuration. Producing 830 horsepower, it features twin compressors to boost performance under demanding conditions. Weighing around 4 metric tons, this engine delivers exceptional torque, reliability, and durability, making it ideal for the Bergepanzer's dual roles in mobility and recovery operations. Built for heavy-duty performance, it ensures dependable operation in the toughest environments. The Deutz BF8M1015CP is a water-cooled, turbocharged V8 diesel engine engineered for heavy-duty industrial and mobile applications. Equipped with intercooling and an advanced fuel injection system, it delivers high power, fuel efficiency, and low emissions. Commonly used in construction equipment, marine vessels, and power generation, this engine is built for continuous operation under tough conditions. Known for its durability, easy maintenance, and long service life, the BF8M1015CP is a reliable choice for demanding environments. The Waterloo Boy was a groundbreaking series of tractors originally produced by the Waterloo Gasoline Engine Company, later acquired by John Deere in 1918. Marking Deere's entry into the tractor market. Known for their simplicity, reliability, and affordability, these tractors played a key role in the early mechanization of agriculture. Powered by a robust two-cylinder kerosene engine, the Waterloo Boy offered farmers a cost-effective alternative to gasoline-powered machines. Easy to operate and maintain, it quickly gained popularity in rural communities. The Model N became the top-selling variant, while the Model R introduced design improvements like a lighter frame and modern radiator. Production continued until 1923, when the Waterloo Boy name was retired and fully absorbed into the John Deere lineup. The Waterloo Boy's success laid the foundation for John Deere's rise as a global leader in tractor manufacturing. A legacy still honored today as tractor production continuing in Waterloo, Iowa. It remains an enduring symbol of innovation and progress in agricultural history. The Continental R975C4 is a 9-cylinder, air-cooled radial gasoline engine developed in the late 1930s and widely used during World War II, most notably in early models of the M4 and M4A1 Sherman tanks. With a displacement of 975 cubic inches and output of around 400 horsepower, it enabled the 33-ton Sherman to reach speeds of 24 to 26 miles per hour. Originally adapted from aviation designs, the engine's radial configuration offered a compact, powerful layout ideal for tanks. Its air-cooled system eliminated the need for complex radiators, but required careful airflow management to avoid overheating. The 9-cylinder Radial delivered smooth operation and a solid power-to-weight ratio. The R975C4 played a key role in the M4A 176mm HVSS, a late-war Sherman variant featuring an improved horizontal volute spring suspension and a more powerful 76mm gun, enhancing mobility and firepower. The first start after a full rebuild is a milestone. Every component, from pistons to ignition, is restored to factory specs. Once reassembled, the engine undergoes timing and lubrication checks before firing up, its distinctive radial rumble marking the return of a World War II legend. This particular R975C4 will be installed in a fully restored Sherman M4A 176mm HVSS, combining historical authenticity with operational readiness. It stands as a tribute to 1940s engineering and to the modern craftsman keeping military heritage alive. Starting a 350 HP, 2,400 volts synchronous motor typically begins by operating it as an induction motor. Initially, AC power is applied to the stator only, with no DC excitation to the rotor field winding. This induces currents in the damper, amortisseur windings, allowing the motor to accelerate smoothly like an induction motor. Once the rotor nears synchronous speed, DC excitation is applied to the rotor field winding, creating a stable magnetic field. This field locks in with the stator's rotating magnetic field, allowing the rotor to pull into synchronous and run at constant synchronous speed, determined solely by supply frequency and the number of poles. Damper windings provide starting torque, while the excitation system, static or rotating, ensures field generation. Adjusting field excitation also helps improve power factor, a key benefit in industrial settings. Since starting torque is lower than running torque, the motor must not be overloaded during startup. If the pull-out torque is exceeded, the motor can lose synchronism and stop. A properly managed starting sequence ensures reliable and efficient operation. The MAN F6V35, a six-cylinder submarine diesel engine built in 1917 by Blohm and Voss, uses a unique air-assisted fuel injection system requiring up to 80 bars of pressure. Because its four-stage injection air compressor only operates once the engine is running, an external compressor is first used to charge the system. A separate 20-bar starting air supply is also prepared to rotate the pistons and initiate combustion. Before starting, cooling water flow is verified to protect the water-cooled exhaust valves, and the engine's connected 480 kV AAC generator, built in 1944, is checked and cleaned, with load regulation set to a water resistor. With fuel, lubrication, and air systems ready, the engine is cranked using the 20-bar air supply, while 80-bar injection air atomizes and delivers diesel to the cylinders. Once combustion begins, the engine accelerates and takes over compression loops with its own onboard compressor. This precise startup sequence allows the MAN F6V35, originally designed for